Login accepted.
All right, so we're gonna get started. Sorry for the delay. We're having some mic issues on our end. The thing just decided not to charge, so we'll be using my laptop mic instead. That being said, welcome everyone to week 3, hacking web applications. The sign-in link is right up there. It's been up there for a while now, so gonna kind of just move on. Actually, it sounds like people are still signing in. I'll leave it up for a little longer. All right, we're just gonna move on for now. All right, so week 3 is brought to you by the same people. So same person here. I'm Derek, CP alumni, been on the competition team for 2 years. Nothing's changed since I last introduced myself. So yeah.
My name is Maxwell. I go by Max. I'm a 4th year CIS. Last year for CPTC, I was the Linux that turned into the cloud lead. But you know that from last week.
All right, so for the agenda, or at least what's going on for the boot camps. We're almost at the halfway point. We're starting some of the more actual technical stuff starting this week. This week, we're actually going to be dealing with some web applications, and you can see the schedule for the rest of the weeks. So last week, we covered about the penetration testing methodology, and this week, we'll be talking more about web applications. And just keep in mind, there's always going to be a methodology for everything, so there's going to be a lot to learn. We also talked a little bit about Kali. Also be familiar with that because it's probably going to be a useful thing to be using this week. We also talked about the client server model, which will come into play again this week as well. And last week, we also covered ports, network connections, and the different kinds of shells. All right, so for today's agenda, 4 sections, just like last week. First off, we got the basics of web apps and how do they work in general. Then we're going to cover the web application penetration testing methodology. And we're going to round it out with some actual vulnerabilities of web applications. And then after that, we're gonna show you guys a little lab for you guys to be working on for the remainder of the meeting. That being said, to start things off, what are web applications? So web apps are interactive web pages. And I bring this up because in the early days of the internet, there's a lot of static sites. And what I mean by that is you visit a site and you can't really do anything with it. You just look up a bunch of info. But nowadays, web applications are actually pretty dynamic. Like they're fully interactive. Like let's take, for example, the same examples I've been using last week, Amazon, right? When you add something to your cart and buy it, it's not just for show. You end up actually like spending your money and the item comes to your door, right? So yeah, that client server model kind of comes into play here within web apps because it's very relative. You're the client, you're the user trying to reach out to the web application for its resource. The web servers are what's hosting the service that you want. And there's a number of different kinds of services that web applications provide. Amazon is just one of like hundreds of examples out there. You got YouTube, you got many other places that provide many unique and different kinds of services. Yeah. So how do web applications actually work? So last week we talked about how ports are the way that computers talk to each other. Well, we talk to web applications using the HTTP protocol. You don't have to know exactly the ins and outs of how it works. You just gotta know that the protocol is just how you kind of speak with the website. So it kind of comes in these little phases that you can split into how the client sends a request, how the server processes or handles the request, and how the server from there sends you the response. So starting from the top, you first make your HTTP request, right? What that means is you're trying to communicate with the website and you're crafting some kind of message to it. Let's take that, what do you call it? The attendance form, for example, right? When you're filling out that form, you add in your email, you add in your names and such, you're crafting that HTTP message. And by the time you hit that send button, that's when you actually send the HTTP request, which is the second step there. So after you send the message, now the ball is in the server's ballpark. And that's whether the server actually receives the HTTP request, and now it's trying to determine what you kind of want. So based on the information that you sent to the website, it's up to the server to kind of determine what kind of resource that you're trying to look for, or from there, try to run the requested function or process. And again, this goes with how many different kinds of services are out there. It could be a lookup from a database, some kind of command execution, or like a file read and write. Like for example, right, with the Amazon example, when you're searching up some items on there, it's probably querying like a database or something to pull up those items and the prices and how much they have left, for example. All that's done through like some kind of database to house all that data. Command execution, don't got an example off the top of my head, but like file reading, websites have a bunch of web pages, right? And how do you think that you view those? Most of the time, you're just doing kind of a file read, just viewing some kind of resource from the page. And those are like the services that the web applications can provide. And from there, the server attaches some kind of response code in the response to you. So that response can vary, just depends on what you ask for. So there's many different ways to communicate with a web application. So here is like the different kinds of request methods. There's a lot. There's get, post, put, delete, head, and options. But really, you only gotta look at the top two because those are the most common ones. A get request is simply just asking a web server for like a resource. So something as simple as just surfing the internet mindlessly, opening up a web page, that's as simple as requesting a resource. There you go. A post request is when you actually send data to the server for it to process. So back with that attendance form that you guys hopefully filled out earlier, you're sending in your email, your name, and all that good information, and you got to send it to the server for it to process. And at least in our end, or at least in our case, that server processes it in a way to log it to an Excel sheet, so we have all your information up there. Put, delete, head, and options. These are some extra ones that I personally haven't seen very often. Putting puts a resource on a server, delete deletes a resource on a server. Head just gets kind of like heading a file in Linux, request a page without its contents, just like the very top of it kind of thing. And options just shows you the log methods. Personally, I see post handle a lot of these things, like the put and delete ones. Usually when you like kind of post to an endpoint, the process kind of, or the server processes it in a way to do some of these actions already. So most of the times, just look at the top two, get and post. Those are the most common ones. So I mentioned earlier that HTTP response, or when the server responds to you, it comes attached with some kind of response code. So there's many different kinds of categories. You don't have to memorize them all, but here's the kind of general overview of them. We first got like the 100 series, which are known as like just information. So there's many different kinds. I don't even know them off the top of my head, but these are some kinds of ways to disclose some information. The 200 series, what do you call it? Just get this little question in here. Right. Thanks, Lon. The 200 series response codes are any kind of success messages. The most common one being the, what do you call it? The 200 or 200 OK message. The 300 series, roughly just the redirects, client errors being the 400 and 500 being the server errors. We'll talk about some of the more prevalent ones that you may see on a day-to-day basis. I just mentioned the 200 OK message. That one is just like when you go around to visit a website and you successfully requested it. Now you may not see like an explicit 200, but if you're analyzing your response that you get through some tools and such, you can see that you said, oh, it's a successful request. You get that 200 message and you get all the contents that you're looking for. Permanent redirection here. So that's a 301. That's like when you try to visit a website, but if you type something up into your URL bar, you notice that you move to a different site. So I guess an example nowadays is like if you try to go on Twitter, it redirects you to X. I think that's an example of a permanent redirection there. I'm not sure if you get a 301 or you get something else, but the idea is there. Next, the two most common errors, at least in my opinion, the ones I run into the most, access denied and not found. So these are the 400 errors, right? You might get that 403 when you try to visit something that you're not supposed to. Like say there's a website with an admin panel and you don't have credits or you don't have like a session on there. Well, it's not going to allow you onto there, at least assuming that the website is set up properly. And if you try to visit a page that doesn't exist, you're going to get a 404. And if it's not your error, right, it's going to be the server somehow. Well, you might be thrown a 500 error, which is just an internal server error. So this is just a quick example of a post request. In this case, I'm hitting up something called purchase.php in that red little line up very top. That little blob of text AC that's lined in the headers, this information is, well, I was talking about earlier how the web server tries to, excuse me, determine what to do with your requests. It uses a lot of these headers to kind of determine what you are trying to do. So there's a lot of good information up here, like the origin of where the request was sent from, the refer, like your cookie if you have one, user agents and hosts, and there's a lot of information up there. So that's the headers. It's kind of just like the metadata of your packet that you're sending over, that you're communicating with the server. And then we got followed up with the owner IDs and the recipient ID. That part is known as the body of the post request. This is the actual data that you're sending to the server. So whatever this case may be, it's just expecting these two parameters to perform some kind of action. And I'll hand it off to Max.
Yeah, so now that we covered the request, this is generally what we'll see from the response from the server. So it's a similar structure to a request, but instead at our response line, we see a response code, in this case 200 OK, so everything's good. Similar headers. The one that I kind of want to point out is set cookie. So cookies are basically little files or bits of information that get stored in your browser that is sent from a website. An example of a cookie, they could be used for like a website's preferences. So let's say, for example, if you want to use the dark mode on a website, that could be stored as a cookie. So every time that you go back to that website on a browser, it'll know that. And so you don't have to change it every single time. Going down to the body, this is, in this case, it's the HTML. It's what you're actually looking at in your web browser. It doesn't just have to be HTML. If you're working with APIs, you're going to see a lot of things like JSON or kind of just formatted data to work with. Then if you look below, it's kind of just a key or a legend of basically what I just talked about. Right, so the three types of data lifetimes. First one being application or store. This is data that's stored on a server, or in most cases, a database. It's pretty persistent. You're not going to have much control over that. It's going to last long after your login or anything, which brings me to the next one, which is session. This is either stored on the client or the server, and it only lasts for the duration of your session. So in this case, for example, a session could be for the amount of time that you're logged in. Let's say if you're logged in, you can see a bunch of different information or make changes. But once you log out, you can't see it or it's gone. Last is request. This is only data that lasts for let's say one web request. One example would just be a simple Google search. Google will handle your request, and then it'll basically just throw it away. It did its job, it's done. Moving on. So now we're going to be looking at some server-side code. This is basically going to go over how the server handles a request made from us. So in this case, we're using PHP. If you don't know how to use PHP or code in general, that's fine. I'm going to kind of break it down, just kind of like the general methodology. Once you kind of get a little bit of practice, no matter the language, you can kind of understand what it's trying to do. So in this case, if we look at the if statement, we're going to be saying if the request is a post request and the variable btn or button is set, which means that it has a value, then it'll proceed. So basically it sets a bunch of different variables, also data from our post request. And then moving down, it goes to the SQL query, which is a database. So basically it'll take all our information from the post request, and then we're seeing it is inserting that data into the grocery TV table or database. So that might be a little confusing at first, but it's basically just trying to get you to get used to how a server takes a request, kind of breaks it down, takes the information that it wants, does what it wants to do, in this case, insert it into a table, and then it kind of gives us a response. And then I'll hand it back to Derek.
All right. This section is my favorite because I added a couple animations. Hopefully that helps with the audience retention of this. I just want to have some fun. So section 2, web application penetration testing methodology. So last week we talked about like the overall penetration testing methodology. This one's more catered to just web applications in general. And there's many different kinds of phases, at least in the previous place that I interned at last summer, they had 7 phases up, but to kind of condense the information, because a lot of them are pretty similar, it can kind of be boiled down to these 3 main steps. We got discovery, configuration, and data validation. So let's start off with the discovery side of things, right? So when you handle a web application, it's important for you to try to discover as much information as you can. Each web application is, what do you call it? Unique enough to be that like, just because you tried out for something for web application A doesn't mean that's going to work out for web application B. Like if they're two completely, for example, if they are running on 2 completely different backend languages, they may not like, just because an exploit for this one worked doesn't mean it's going to work for that one. So that kind of comes in with the application fingerprinting. You're trying to learn as much about the tech stack, about the web application in general, because I can't stress this enough, but within web applications, information is seriously going to be powerful for you. Information here helps you kind of narrow down your options to better aim your assessment kind of thing. In this phase, you'll be kind of scanning the web application as well. So web applications have plenty of different pages, right? And in those pages, they might have some functionalities. So it's pretty good to just kind of crawl over the site to try to take note of anything you can find on the site. So yeah, that's pretty much it for discovery. Next up, we're going to talk about the configuration of the website, of the web application, excuse me. So this stuff here, there's a lot of things to be looking out for when it comes to how the website is configured. We got version numbers and its settings most predominantly here. So let's use an example here for version numbers. Not sure how many of you have heard of WordPress, but it's a pretty common blogging website, CMS or content management system. And it has a bunch of different versions. And just like with how you have your computers and you update it every so often, it's for the same reason. It's for the security reasons. That being said, if you happen to come across an outdated WordPress application, there might be a plethora of different kinds of vulnerabilities that may be attached with it. So it's always good to keep an eye out for version numbers because, well, if they're outdated, it's probably for a reason. So it's probably going to be insecure. Also, using the same example, WordPress here, there's some couple settings you might want to look out for. At least the one I'm talking about here is like there's a certain file within WordPress, at least how it's done. It's called wp-config.php. That's just an example. Don't worry too much about it. But that config file contains some pretty juicy information about like connections to databases or such. So at least in this case, why a database might be important to a web app pen test is because it kind of expands your attack surface. No longer are you just dealing with a web app, but now you have potential information that you could be disclosing from the database. So lots of good things to look out for how the web app is configured, because if it's configured insecurely, well, there's your ticket to a successful assessment, right? So, and lastly, we got data validation. So what is data validation like actually? Like, what does that mean? Well, if you haven't kind of caught into the trend already, a lot of times when you're communicating to a server, there's a lot of user input that's being taken. You're controlling something that the server has to kind of ingest, right? So that being said, can you make it behave improperly? Can you spill an error of some kind? And that might be indicative of some kind of technique that you can use against it. So the data validation, what it just means is that you're trying to make sure that the information you're sending to your web application is valid. So if it's not, does the web application actually handle it properly? Because ideally, if you do give something to the web server that is not supposed to handle, like I'll talk about this in a little bit later on about like SQL injection, for example. If you're trying to like put something kind of funny to the website, will it actually handle your requests like a SQL request, or will it just try to filter it out and be like, you're trying to do something funky to my web app? So yeah, data validation, just trying to make sure that everything's all secure. All right, and that's it for my animations. So some tools to be using for these phases that we're talking about, right? So Wappalizer is just a simple browser plugin that you can be using. And this really helps out with the fingerprinting part of the discovery phase. So like I said earlier, each web application is going to be unique to an extent, right? And in this case, what Wappalizer told me is that this thing has all that. It has WordPress, At20, WooCommerce, Google Analytics, Salesforce stuff, and even a MySQL database, right? So right off the bat, we see like a WordPress 6.2.2. That's pretty interesting considering that is pretty outdated. I think WordPress is on like 8 point something now. So that thing is pretty far out of date. So if I had permission to, I would be doing something kind of funny with this website. Otherwise, don't touch it because that's illegal. But yeah, Wappalizer, just a very simple browser plugin, does some little recon for you, just gets a nice idea of what the website is like. Next up, we got Burp Suite. And oh my goodness, this is the tool for web applications. It is the Swiss Army knife. There are so many things that this thing can do. And if I were to explain it all, it would take another hour. So I'm going to try to condense it down as much as I can. Pretty much what Burp Suite does is it interacts with, it's able to proxy your requests to the web server. So like how I mentioned earlier, when you try to go up to a website and request some information or such, what you could do is before you send that request, you can have Burp Suite kind of proxy that, inspect the request that you're sending before you actually send it. And likewise, before the server sends a response back to you, it can also inspect that response. So it's pretty neat. Burp Suite's got a lot of cool tools. You also see in like it's kind of hard to see up there, but there's like intruder and repeater. Intruder is like a brute force tool. So if you come across like a login page, for example, and you're like, I want the admin account, you could simply just fill out the admin's username and like leave a variable for the, for the password and supply a word list, and boom, Burp Suite's going to kind of run that through. Do keep in mind though, if you do plan to use Intruder on Burp Suite, at least the community edition, it is heavily throttled, so it's going to be a lot slower than you would like it to be. Otherwise, Burp Suite Pro, it says peace to throttling, and it just goes extremely quickly. And we also got Repeater. So when you send a request to a server, right, and you want to make some adjustments to it because you're kind of just playing around with how the web application is kind of behaving, instead of going back to the web app and try to manually fill out everything you want to do and repeat the request, you can just press Control-R on the what do you call it? So you see this little HTTP history tab. This is like kind of like your history that you're dealing with here, like the request that you sent in the past, and you can just repeat that request. So in this case over here, right, you see this looks very similar to the response example that we had earlier, or excuse me, the request example, a post request example that we had earlier with the username, password, confirmed password, wallet ID, and such. So in this case, if I were to repeat this request and change the username into Derek, what would happen, right? Oh, all of a sudden I created a username Derek. I wonder how that happened. But you basically repeated a request that you had in the past. So yeah, that's Burp Suite. A lot of other cool things with it, but that's at a high level of what it's able to do. So to finish off the tools, handing it back to Max.
Yeah, so to the fun tools. GoBuster is a brute forcing tool. In this case, we're using its directory module, mode, whatever. So we use this tool to find not only directories, but also web pages. You can think of web directories kind of similar to a file system in that, for example, if you think of websites such as Wikipedia, not all of its information is just on one page. If you look at a Wikipedia URL, you're going to see directories separated by slashes. This not only helps with organization, but it also helps with serving you with the content that you actually want. So in this case, not every directory or web page is just going to be openly available to you. We're going to have to kind of look for them. In this case, we're going to scan or brute force. So looking at the command example that we used, we say GoBuster and then dir for the directory module. And we're going to supply the URL such as redemption.nft in this case that we're going to scan. And then we're going to use -r, which is the word list, which we'll touch on in a bit, but it's basically just a list of words. And then X for PHP. So let's say from our initial enumeration, we find that this website is using PHP as a backend. Well, with the scan, we're going to want to look for PHP files. So with the -x or extension flag, it'll add .php to each word in our word list. And if we look at the command output, we see that we find search.php, and GoBuster is nice enough to show us the status code. As long along with the size, which I believe is in bytes, if I'm not mistaken. A few other examples of statuses are 403, which is forbidden, like Derek went over earlier. Basically, this means that it exists, but we don't have permission to it. And then 302, which is a redirect. And we could also see what it redirects to. So we know that in order to browse to listing.php, we must first be logged in because it redirects us to the login page. Yeah, so GoBuster is just a tool, and it basically will filter out all the bad requests, all the 404s, obviously stuff that doesn't exist, it won't show us. This is just one tool. There's plenty of other directory brute forcers or scanners available. This is just kind of a classic and pretty easy to pick up. All right, so we kind of touched on word lists, but I'll go a little bit more into depth. Like I said, they're very just large text files with a bunch of different words on each line that we feed these tools, and they will just basically run through all of them. There are certain word lists for certain uses. For example, here, passwords, directories, or as well as vhosts, virtual hosts, or subdomains. These are all pre-installed on Kali Linux. That is why, and so the full directory path is here, such as user share word lists or sec lists. You're definitely going to be using these. If you've ever done any CTFs or try hack me, hack the box, you're probably going to know what rocky.txt is. It's your pretty basic just list of common passwords that most CTFs use. Next up, our next tool is SQL Map. I know we haven't touched on SQL injection quite yet, but just basically think this is just the automated version of a SQL injection. One of the biggest like selling points of SQL Map is the relationship and how you could use it with Burp Suite, so to say. How you can export a request from Burp Suite, save it in a text file such as we have here, as a named req or request.txt, and it'll basically run through every input variable that the request has and look for SQL injections. Yeah, using the attack R flag. You can also do it manually and specify a specific input variable, but to be honest, this is just very kind of like the quick, easy win. But now Derek will
Just to add on to that,
Oh, yeah.
actually, before we move on. Little funny story from last year's CPTC. We came across an endpoint that we thought was potentially SQL injectable, and we had Max just run through the tool with like the highest settings, like the most sensitive ones possible, and we basically got turned up with nothing, right? And Max just dropped the ball and said, "Well, if SQL Map can't do it, I can't do it," and that's pretty true because SQL Map is probably going to be doing at least what you're trying to be doing manually, but automatically and very, very quickly, and helps you save a lot of time. That isn't to say that you might spot some different holes that SQL might not be able to cover, but if you're at least trying to cover the low-hanging fruit stuff, SQL Map's going to cover your butt in that case.
Yeah, SQL Map doesn't have a 100% success rate. Obviously, it's good to know how the vulnerability actually works, which Derek will describe now.
Yeah, that's right. Section 3, web application vulnerabilities. So that little subtitle that we got there, sanitize all inputs. That part is, it's a common trend for the base of a lot of different kinds of web application attacks. So the one that I keep on talking about throughout the entire presentation, SQL injection. So here it is. What is SQL injection actually? So first of all, before talking about SQL injection, I'm gonna talk about what SQL actually is. And SQL is a kind of a query language that a lot of databases will use. If anybody's out there who's worked with database before, you might be familiar with MySQL, Postgres, NoSQL. There's many different kinds, but at least in this case, this is an example of a MySQL query up here. So that being said, databases to retrieve information use the SQL query language to retrieve information from it, right? So SQL injections kind of abuse that a little bit. So more than a little bit actually. But so in this little example here, we have redemption.nft, and you're going to be hitting up this endpoint called search.php, and it's going to take in one of those variables and called Q, and it's going to assign the value LMAO. Just for context, this is all on your end, so you have full control over that line. And like with how Max was mentioning earlier, the server is going to take this information and bind it to something on the back end. At least in this case, I have a little snippet here of what it shows. It's going to select from listing where listing name equals LMAO. So hold on, what does that mean? Select means you just kind of grab all the information because we specify a wildcard, and that just means grab everything, right? And at least within SQL, SQL uses tables to kind of organize their data. And at least in this case, we're going to be looking from the listing table. So we want to select everything from this table named listing, where the item name that we're looking for, since we're on the search.php function, right? That we're going to look for something that looks like LMAO. So to take a step back of what is just happening, pretty much you're telling the web app to make a SQL query to a database. So how do we actually play around with this, right? So it's kind of hard to do this blind, but that's just what it is with web applications. But if you happen to have a snippet of the backend code, kind of like how I provide up here, you can kind of infer some kind of attack over there. So what is all that jargon there? So after LMAO, I put in a bunch of different willy-nilly characters, right? I put a percent sign, single quote, parentheses, or plus sign, 1 = 1, dash, dash, space, dash. Now, what does that all mean? That's why I broke it down to different colors to help differentiate which each part is. So that section in green, right? The percent sign, single quote, and parentheses. Now, if you take a look at that backend code, right? You have control at that LMAO point, right? So you kind of want to try to, the idea within a SQL injection is to try to craft a SQL query that is still valid so that you can return some kind of information here. So in this case, we know, because we happen to have the source code, that this is how it looks like in the back end. So if I try to put in that percent sign, single quote, and parentheses, that kind of rounds out the rest of that little statement up there. So that finishes the first statement. So it's valid, but that's not going to be exactly useful just yet. That next part, the or 1 = 1. And if you're wondering why there's like a plus sign versus no plus sign in the other part, plus signs in the URL is just a URL encoded version of a space character. So you can think of plus signs as just spaces in between. So or 1 = 1 is a Boolean statement. What Boolean is just means true or false. And actually, that's basically what it is. But if anyone has taken any kind of logic class, you know that or is that for an or clause to be true, one side of the statement has to be true. And if it is, then it's going to kind of return to you that statement that you're looking for. In this case, we're looking for all the information from listing, right? But in our original statement, we're looking for everything that looks like LMAO. But if we put that or clause into there, and 1 = 1, and in what world does 1 not equal 1? It always returns true, right? So since that is always true, regardless of whether or not LMAO exists in that little search thing that we're looking for, because if you just go onto like a website and try to search up LMAO, maybe you get nothing, right? But in this case, since 1 = 1 is always going to be true, you're going to be pulling all this information here. And that last part over here, the dash dash space dash, that's just to comment out the rest of the code. Like I mentioned earlier with SQL injections, you want to make sure that your statement is still valid. So up until this point, we know that our statement is still valid, but if there's still like an addendum to the statement that we have here that we just don't see the rest of it, excuse me, this kind of just comments out the rest of it to kind of just tell the backend to disregard the rest of the statement. So what does this actually return? This is going to pull up everything from the listing table. So in the original statement, we're looking for something that just looked like LMAO. In this statement here that we put up with a carefully crafted SQL injection payload, you're able to actually pull up everything. So this is just one example of the SQL injection. There's many other different kinds of payloads to do whatever you want. But the moment that you find out that you have some sort of degree of control over the web application and are able to disclose this kind of information, you know that you're primed to be able to have some fun with some kinds of SQL injections. Just know that like these things are considered critical vulnerabilities because there's been a lot of database leaks on like major companies in general in the past just from exploiting SQL like this. So yeah, next up, we got command injection. So this thing is very similar to SQL injection, but this time, rather than injecting some sort of SQL command, we're doing like a literal command. Now, most of you guys have probably done Bandit from last week, and you may be familiar with how when you run a command on that terminal, you get its output. Like when you run ls, you return all the directory contents of the current directory that you're in or this directory that you specified, right? So in this case, if a web application is performing some kind of, some kind of command in the backend, regardless of what that may be, you may be able to kind of inject into it and also do something that you want to do. So at least in this example that we have here, once again, with that redemption, that NFT site, we're going to be looking at the purchase.php endpoint, and it's going to take two parameters. It's going to take the owner ID and the recipient ID. Now, from our end, we don't exactly know what that's doing, but for the sake of this example, we're going to assume that it's going to run a command on these two parameters in the backend. So how do we actually execute this? So we see up here that at least in a normal post request, like what it's actually expecting you to do is provide you, or for you to provide them with those two parameters. And in this case, purchase.php will trade an item by swapping the owner ID and the recipient ID. So it's just going to flip them, right? But let's pretend that's doing something like that requires some kind of shell command in the backend. So if you know that, I mean, since you're able to supply that 24 and 25, if you add like a semicolon in bash, what you're doing is you're telling it to run the command that you run previously and the one that you're telling it to run right now. So you can just slap on a whole new command right on top of it, and it'll run them consecutively. So yeah, just like I mentioned right there, injecting a command into a post request, the purchase.php will still swap those IDs that we were talking about, but it will also, because of the semicolon, run that command that you're specifying. Now, what kinds of commands are we limited to? Kind of depends on the actual machine itself, whether or not it has the commands or not. But for sake of simplicity, a good old reliable test is just a quick ping test. So here, we see this a couple times now. This is the example of post request, right? Once again, that big old top section is just all the headers, but that part that's being highlighted is the data, the part that you're actually sending to the server and the part that we're injecting to. So that part in like that rose color, that owner ID, recipient ID, that's the normal stuff. That's the part that the web application is expecting you to send. But since we have control over this, I'm going to slap on a semicolon and do a little ping taxi2, which just means I'm going to ping a machine 2 times. And in this case, those XXXs, just replace it with your IP. And on your end, if you set up something like a TCP dump, if you see some request come back to you, you know, like, oh shoot, I just got that server to do a command. So no longer are you just limited to pings, because ping is just like a POC in this case, just a proof of concept to see if something will work. Now you can do like maybe like an LS. Well, most of the times you won't be seeing output from an LS, because when you run a command on the terminal, it doesn't mean it's going to feed it back to you, but it probably ran on their end. So like with how we were talking about in the first week with the shells and such, if you pop a reverse shell over here, all of a sudden you have full remote access to a web application. Passing it over to Max over here.
Yeah, so now getting into local/remote file inclusion. This is basically a way that we can trick a server into accessing a file that it's not supposed to or it's not intending to. For example, an example of local file inclusion, it's kind of self-explanatory. We trick the web server into loading a file locally or on the server. And remote file inclusion, we trick the server into loading a file from a remote area, such as our own web server, or basically just anywhere else from the internet or the internal network. So basically, if you see, like in the example below, the browse.php file has a file parameter, and it's looking for sync.png. Basically, when you see something looking for a file, you always kind of want to test for these things. So if we move on, this will kind of break down similar to what I said. So the main thing that we want to change and that we have control over is the image or the file that it's looking for. In this case, sync.png. So testing for RFI, if we replace sync.png with something, it's kind of just an example of a random IP, but this could be our own file server hosting an evil PHP or a malicious script. So let's say if we replace that and then we see a hit on our file server that the server downloaded it or ran the file, then that's obviously not supposed to happen. LFI, it might look weird with all the dots and slashes, but this is basically just treating it like a file system in a command line. It means that you're going back a directory until we eventually get to the root. which is where Etsy password is. It's basically just a reliable file that's on basically every web server. And it also includes some user information. You should consider post parameters too. It's not just get parameters, but basically, if you see a file, if you have control over a file, you want to look for LFI or RFI. Next up is server-side request forgery. So similar to the thought process of if you see a file that you could kind of control. In this case, it's if you see a URL. So basically, server-side request forgery, you're gonna forge or make the server make a request on its behalf. So in this example, on the left side, we see the legitimate requests. We could assume that this is some sort of web shop, and it uses its stock API to show you all the items that are in stock. So as you can see, the left is the legitimate. It uses its API, whatever, all the filters that it wants you to show. Well, if we replace that with a URL to localhost or the server itself, an admin, and then we press enter or send the request, and then all of a sudden its admin page loads. Again, that's not supposed to happen, and we could get a lot of information for that. So just to reiterate, if you see a URL or an IP address, you kind of want to test for something like server-side request forgery. Last but not least, insecure access controls. So this is kind of like a tree of general access controls, or basically ways that a web server kind of controls where and what you have access to. The first insecure way is insecure direct object reference, or IDOR. Again, get used to acronyms. You don't have to memorize all of them, but IDOR. So let's say, for an example, let's say if I log into a website and I want to check my receipt for a transaction that I've done. And then I see in the URL, it says transaction ID. Sorry, excuse me. A transaction ID of 1, let's say. If I'm logged in and I change that 1 to 2, and I see someone else's transaction ID and address and credit card, that's an insecure direct object reference, because it is just relying on that ID and not the actual permissions of my user. Next up is parameter-based access methods. This goes back to when we were talking about sessions and login sessions. Some of these sessions use cookies, and basically, sometimes you'll see a cookie with your permissions in there. So if you look under, it says admin 0. Well, since we have control over the cookie just in our browser, and if we change that 0 to 1, and we get then we get admin permission, again, that's unintended. So that would be a parameter-based access method example. Third one is refer-based access control. I believe Derek went over it, but a refer is a header. So in this example, the website is basically saying that unless you are coming from the admin panel, you won't be able to access the delete user endpoint. In this case, we can just edit our own request and make sure that we're coming from admin, but we really aren't. Again, this is just 3 examples of insecure access controls. There's plenty more. Basically, just think of what you have control over, and then kind of just go from there and mess around with that.
Actually, something I want to add on to that.
Yeah, go ahead.
Just a quick little example about the refer-based access controls. A lot of video hosting sites won't allow you to directly access the video, but it will allow you to play the video within the site. So how does it differentiate the two? When you're viewing the video from the site, it's calling the refer from itself, right? But if you try to access the video by yourself, like you found like through inspect elements, oh, I see the video is that stored over here in this URL. If you try to access that yourself, it's going to give you a denied. But if you proxy your request and add in a refer that is the website, all of a sudden you have access to that video. I was playing around with some stuff recently. Anyways, yeah. Back to you, Max. This one I have that.
I think that's it.
Oh.
So, do you want to explain it? Well,
So-
now we're moving on. Sorry, I'll finish. So that was kind of just like some high level, I could see could be a little boring just explaining it. So now we're gonna get actually hands-on in our lab/homework that Derek made.
All right. So, the link to the homework is up there. It has the document. And pretty much, what the document's gonna be talking about is there's two major sections. Maybe I should just pull this up actually, so I don't have to talk to just like that board up there. But I'm gonna leave that there for a minute for you guys to get the homework link. It will be sent out on Discord, eventually, but, it's gonna be up here for now. So just leave it up for a second before I pull it up. Oh, that's great. All right, that's wonderful. I should have stayed up the extra hour then. Oh, well, okay, so. Is my screen still sharing? Wrong part. Let me share something else. Stop my share, but I'm gonna share a different part here. I'm gonna share the, my browser real quick. All right.
Leak.
Oh no. Bro, these controls aren't letting me control tab. Amazing. All right. Oh, that just went through my drive, didn't it? Oh well. All right, so the week 3 homework. Like I mentioned, the first section here is going to be covering just some general question or a general question. So you're going to be selecting from this pool of 9 or even more. Those 9 are just for an example, but you're just going to be comparing and contrasting two web application vulnerabilities. I do want to point out that the ones in yellow, you can't pick 2 of the same ones in there. I do know that based on last year's homework submissions, because this is a reused assignment from last year, a lot of people just picked the top 3 and there was no diversity. I want to see some different responses out there. So I'm going to make it a little more difficult here. So yeah, just some things to consider in all these. There's like some prerequisites to look at. Like, what do you need in order for like a actual vulnerability to be considered a vulnerability, or for that thing to be to actually be exploitable, right? Some toolings or techniques that are used to actually perform it. The impact of certain vulnerabilities, because not all of them are cut from the same cloth. Some of them are going to be more damaging than others, right? Some of them are going to have a bigger impact. So just kind of keep that in mind. And also the steps to actually remediate there. So that's just gonna be the first part, worth half of the credit this week. And then the second section, the actual lab part. So, have we gone over how to access Camino? If not, I should probably link the document.
No.
Okay,
We'll
so
link the document.
I'll add on to the document in a bit, but pretty much you're gonna be accessing Camino to deploy your own pod. I have the website set up, and lo and behold, it's that redemption NFT that I've been bullying for that Max and I've been bullying the entire presentation. So it's gonna be kind of fun. Redemption NFT is a site that Gabe has created that I've also added onto. It's a very wonderful NFT trading application, but pretty much everyone's gonna have their own personal instance. Just go into Camino and click that drop down on deploy pod. It's going to see a little CPTC web. Just click on that one and deploy it. I do realize that when I was working on this last night, that I only put up the web server there and not the actual Kali machine itself. So unless you have the tools on your end, or if you already have a Kali, then you might just be staring at a website for now. But Marshall and I are going to be working on that very soon to get that sorted out. But yeah, within that website here, we got some guiding questions worth 30 points. Just going to be talking about I'm going to be grading, at least for the most part, on both accuracy and effort. So even if your answers are wrong, don't worry about it. So long as I see effort, you'll get at least partial credit here. So just five questions here, worth probably 6 points each. What's like the purpose of this application? What's the backend language? Any kind of capabilities with this kind of language that you can kind of take advantage of, and do a little research and like what kind of vulnerabilities are there. And from there, based on what you see, what can you actually do? And the last part here is actually doing the pen test. So based on all the stuff that we talked about earlier, the different kinds of web application vulnerabilities. Now, I will say, to be transparent, that not all the stuff that we set up there were just like an answer sheet. It's not going to be like, oh, Max talk about SSRF. There's going to be SSRF on this thing. No, that's not the case. That we just want to talk about those things. But just try out some different vulnerabilities out there. the slides aren't like a cheat sheet, but yeah, just this part, I just want you guys to write up about two distinct web application vulnerabilities here. So if you happen to find vulnerability A and B, and they're completely separate and unrelated, I want to hear about how you found it, your processes to exploit it, and so on and so forth. But yeah, when you're done with all that, just submit a PDF on Canvas, or if you're not a student, submit it to me or Max. We'll get that sorted out, or even Marshall, Mr. Captain over here. Yeah, just a PDF with all the answers that I would talk about. I would request that the PDF be very clear and labeled. It just makes reading a lot easier. If I'm dealing with the text blob, I'm just gonna cry. And if there's like 30 of them, oh, that's gonna be a nightmare.
Yeah, I think I said it in the Discord, our last meeting or so, but screenshots definitely help with documentation. They're kind of just proof. I mean, I know you could edit pictures, but nobody really does that much. Nobody goes that far. So, yeah. Keep your responses, you don't have to put a paragraph for each step that you did. Just kind of just make it clear and concise, as Derek pretty much said.
Yeah, I just want to reiterate that because it just makes all of our lives easier to read. After that, just name the file, your first and last name, underscore CPTC homework 3.pdf, and you're good to go. And the remainder of the time, we have what, a little bit over an hour left. Go ahead, visit Camino. I'll need to edit this actually. Camino. Is it camino.calpointswift.org?
I just need a lot of completion.
.org. There we go.
And then I'll also be making a copy of the slides and making it available in a few minutes. So just that you could kind of refer back to them and kind of just look at them and kind of help. Maybe that'll help you during your testing or answering your questions here. So we'll also add that and Camino both to the same doc. Then yeah, I think that's good. All right.
All right. So like I said, remainder of the time, just have fun with the web application that we have set up over here. I'll leave this document up here. I guess I'll just leave the lab part because the questions part, yeah, I'm just gonna leave this here. And for the remainder of the time, I'll just be walking around the room. Somebody keep tapped on Zoom. I will be walking.
Yeah.
When are you going to be posting the Kali Linux thing?